Now we're going to take this same idea and apply it to algebra. You want to divide 3x squared minus 4x plus 5 by x minus 2. So I'm going to draw the same thing that we had before, 3x squared minus 4x plus 5. And I'm going to divide it by x minus 2. And just like we did with numbers, we're going to look at the first thing, and I'm going to color code it just like I did with numbers. I'm going to look at this 3x squared. And I'm going to ask you, is there anything you could multiply x minus 2 by to get part of it to be a 3x squared? Right? And in particular, I'm not going to look at the 2, I'm going to look at the x. What would I have to multiply the x by to get a 3x squared? I'd have to multiply by 3x. So I'll go over my x columns and I'll write a 3x. Because what is 3x times x minus 2? It is 3x squared, and 3x times minus 2, minus 6x. Same process that we did with numbers, right? In numbers, I looked at the 27, and I said, what can I multiply by 13 to get as close to that as possible? And the answer was 2. Because 2 times 13 got me to 26, as close to 27 as possible. So now, I look at the 3x squared, and what could I multiply x minus 2 to get as close as possible to 3x squared? Well, that would be 3x. That would actually give me 3x squared. And then in long division, we subtract it. We're going to do the same thing, but I'm going to make sure you put brackets around this because you have to subtract all of that. Well, the 3x squared minus the 3x squared nicely goes away. That'll be 0. We can write 0 there. You don't need to. What is minus 4x minus a negative 6x? That will be plus 2x. And 5 minus nothing is still plus 5. I switch colors. I have to do this process again. Just like in long division, right? In long division, now that I got the 148, I now looked at the first numbers and saw 14. And I'm like, ooh, I can get 113 out of there. Now what are my first numbers in algebra? My first number in algebra is the 2x. Is there something that I can multiply here to get as close to 2x as possible? Yes. Can you see that you can multiply by 2? So I will put a plus 2 here. 2 times x perfectly is 2x. 2 times negative 2 is minus 4. Put it in brackets and subtract. 2x minus 2x is 0. 5 minus a negative 4 is 9. That will be your remainder. And what does this mean? If we write out the meaning of this, just like we wrote out the meaning with the numbers, this means that if I started off with 3x squared minus 4x plus 5, and I said, I want x minus 2 times something, well, x minus 2 times 3x plus 2 is really, really close. In fact, if you multiply this out, here, I'll just do it in green underneath, look what you get. You're like, oh, you get 3x squared. You get minus 4x, everything is good. But unfortunately, at the end, you get minus 4 instead of the plus 5. Everything else worked out nice. Well, that's where the remainder comes in. The remainder of 9 says, well, it's really close, but you're off by a little bit. We have to add 9 to make it equal. That's where that remainder comes in. Okay. In calculus next year, some of you are going to be doing this technique for solving some difficult integrals. And when we do it, another way of writing this is actually the division. So what does it mean when we write it as a division? That 3x squared minus 4x plus 5 divided by x minus 2, it's going to equal the 3x plus 2 that we got, but the remainder of 9 still would need to be divided by the x minus 2. So this is another form of writing the same thing. Just like in our numbers, we could have written that 2,748 divided by 13 is equal to 211, plus we have 5 left that still needs to be divided by 13. So it's 211 and 5/13. What we're actually doing is sort of like a long method for changing it from a mixed fraction or an improper fraction to a mixed fraction. This is an improper fraction. It's equal to 211 and 5/13 as a mixed fraction. Second one. This time we have a 2x cubed minus x squared minus 2x plus 1, and we're dividing by x plus 1. See if you're following the pattern. What number, I'm going to take out my blue pen, just like I had a blue pen first over there. What number am I going to write up first on the top? You see the pattern? You see that the first thing I would write on top is 2x squared. Because I'm looking at this first one and saying, what could I multiply that by to get 2x cubed? Well, 2x squared times x is 2x cubed. And 2x squared times the plus 1 is plus 2x squared. Put it in brackets and subtract. The number one mistake you're going to make in long division is mental math errors by not being careful. So this will be 0, but minus x squared minus a plus 2 will be minus 3x squared. We still have the minus 2x. We still have the plus 1. Switch colors. Now, my first term is the minus 3x squared. What number am I going to write in purple on top? Close. To get minus 3x? Negative 3x. So we'll write negative 3x times x perfectly is negative 3x squared, and negative 3x times the 1 is negative 3x. Put that in brackets and subtract. Negative 2 minus a negative 3 will be plus 1x, and then we're left with a 1. Switch colors once again, and now my first number is an x. Is there something I can multiply x by to get x? Yes, a 1. So 1 times x is x. 1 times 1 is 1. Put that in brackets and subtract. And what do we get? 0. No remainder. And with this, we're almost done the unit. This is, by the way, this is a short unit. We're just doing the introduction to part 1. And I feel like we're very close to being done this week. But that's good, because we're done 3 units already. As far as where we should be done 4 units, as time-wise. So we're a unit behind. We need to get going a little faster, but this unit's good, because it's quick. It's quick and easy. However, if you think it's quick and easy, you will disappoint yourself and get a mark much lower than you deserve. You still need to work hard in this unit, but if you work hard in this unit, you have a pretty good chance of getting a sticker on this test, this next test, okay? If you think, oh, it's easy so I don't have to work hard, you're going to be mad at yourself for not taking advantage of an easier unit. So still need to work hard. In fact, maybe you even work harder than normal because you're going to get even more benefit from it. So, what is this? Oh, this result is so exciting for the following reason. 1, if I write out what this means that 2x cubed minus x squared minus 2x plus 1 equals x plus 1 times 2x squared minus 3x plus 1 with no remainder. And what you have done for the first time in your life is you have started to factor a cubic. In fact, some of the questions in this unit will be, you have 2x cubed minus x squared plus 2x plus 1. Factor completely. Well, we just found one factor through long division. And if I wanted to factor this completely, can you factor this? Absolutely. It's 2x and x. That's not hard. It's quadratic. It would have to be 1 and 1. And since it's a minus 3, they would both have to be negative. And now we've factored that cubic function completely. On your identities, that page with all the identities on it, where I said you didn't have to do 45, because 45 had a cubic equation that you would have to factor. All right, so we are going to go to example 1. And we're going to divide 2x cubed. Oh. We have a problem. And long division with polynomials has some special rules that don't happen in numbers. Okay? Because polynomials, this is the same polynomial as this one. Would you agree that I can change the order because adding and subtracting doesn't matter? This never happens with numbers. Does anybody ever write 327 like this? And say, I meant 327. I just decide. Sometimes. It happens. I find when I'm copying numbers down, often I will switch a couple numbers when I'm copying them down. And like, it's not good when you're doing phone calls. It's like, hello? And they're like, who is this? And like, oh, sorry, wrong number.
Sometimes I use 327 and I write down the 27 first, and then I have to write the 300, the 3 first.
Are you right? Okay.
Because I remember the 27 because I just said 27 in my head, but it's what I remember.
So you write it first, and then you're like, oh, I have to put the 3. And if you're not paying attention, you put it at the end, right? But anybody who sees this will be like, no, that's 273. You've written it down. So, but polynomials, it doesn't matter, because adding and subtracting doesn't matter. But that's a special rule. Rule number 1, it must be written to make your life easy in descending order. I actually do mail out a lot of things to a bunch of different addresses. And I have to double check the number on the address, because that's something that could be really bad. You're sending someone a big package, and you put the numbers down wrong. It goes to the wrong place. And then that's not good. So, must be written in descending order. And the second one doesn't come up in this one. But we'll need to include zeros if something is missing, a degree is missing. Like, I have a cubic starting with an x cubed. If there was no x squared, I'd have to put a 0x squared in. If there was no x, I'd have to put a 0x. If there was no constant, I'd have to add a 0. So we have to have spacing. This also doesn't happen in numbers, right? You never write 10,042 just for like, oh, I'll just leave out the zeros. They don't mean anything. This is 10,042. Because I just decided not to write the 2 zeros that would have been there. Well, that's not allowed in numbers. In numbers, we have to include the zeros. But it would be really annoying in math if they're like, solve the following question. X to the 100 equals 1, but start off by making sure you write zeros in for all the things that are, oh, that would take forever and be annoying. So in long division, though, we need to hold places. So if things are missing, we'll see it in a couple examples coming up, we need to have zeros. But first, it's written in descending order. So I have my x cubed first, then x squared, then x, then 5. Now I can divide by x minus 1. And I'm going to give you a 30-second head start. We've done some. See how well you've learned from the first two examples. You're going to try it on your own. See if you make no mental math errors. And in 30 seconds, I'll do it, and you can check how you did. How did you do? Did you get a remainder of 8? Okay? That's usually when I'm marking this, the first thing I check is, do you have the same remainder as me? Because that's pretty hard to do if you make a mistake. If you didn't get a remainder of 8, do you see where the first time you made a number wrong? And usually it happens with subtracting negatives.
Why did you put 5x squared?
Okay, so what's happening with this 5x squared here, the purple one,
Or just
the blue one?
at all of them. I didn't have a 5x squared.
Okay, so the first blue 5x squared became because, did you get the 2x cubed minus 2x squared?
Yes.
Okay, and you put it in brackets?
Yeah.
And then we need to subtract.
Yeah.
3x squareds minus a negative 2 would be added.
Okay.
And then I would get the 5.
Yeah, I
Yeah.
accidentally forgot that there was 2.
Yes, and that's what I was saying. Just before this, I was saying the most common mistake is with subtracting negatives, right? We have to remember we're subtracting, that's why the brackets are so important. We're subtracting all of it, okay? And this is why it's important that I got you to try it on your own, because I don't want you to make mistakes. But if you're going to make mistakes, I want you to make them and learn from them, rather than just keep making them over and over and over.
How did you get the 3?
And negative 3,
Or the minus 3x minus
the green one.
Yeah.
So, how did I get the green 3x minus 3? Well, once I had the purple 3x, then I asked myself, my first one was a 3x, what could I multiply x by to get 3x? And I wrote this plus 3 up here. And then I took this plus 3, just like I did in all of the other ones, and I said, well, I would have to multiply that plus 3 times the x minus 1, and 3 times x is a 3x. And 3 times the minus 1 is the minus 3. I put that in brackets and subtract. On the next page, maybe, there we go. On the next page in the box, you have this written. It's called the division statement for division by x minus a. And I like to write the division statement, I'll write it above. P, which is the polynomial you started with, is equal to D, which is what you're dividing by. When you divide something in math, your answer is called a quotient. When you multiply something, your answer is called a product. When you add something, your answer is called a sum. So we call the answer you get your quotient. So your polynomial will always equal your divisor times your quotient plus your remainder. And we did this already in our first examples. We did this in our numbers. Notice I took what I started with, which is our P. We divided by 13 as our divisor. We got 211, which is our quotient, plus our remainder. We wrote this out when we did our first one. Here's the polynomial. We divided by x minus 2. We got 3x plus 2 as a quotient, plus our remainder. Questions? Yeah. Same thing on this one. We started with our polynomial. We divided by x plus 1. We got this as our quotient, and there is a plus remainder here, but that one didn't have a remainder, so our remainder was 0. And the one that we just did, we can now write our division statement for this. We started with 2x cubed plus 3x squared minus 2x plus 5. That was our polynomial. It's equal to, we divided by x minus 1, and we got 2x squared plus 5x plus 3 as our quotient with a remainder of 8. So this is our divisor, this is our quotient, plus our remainder. And this is called the division statement for polynomials. If your remainder is 0, you have actually started to factor. And that's going to be one of the key themes in this unit, is can we factor things bigger than x squared? And the answer is yes. What techniques will we have to do? Do you just guess and check until you get one that works? Well, that might take too long. So we're also going to learn some techniques for doing that. All right, example 2. Okay, I'm going to steal the steps here from example 1. I'm going to paste them on. And I better stop the first video